let's talk about digital signature in this video. So then, what are the essential elements of digital signature? First of all, you have to realize that digital signatures, they still use asymmetric key encryption, which means we use a key pair again. A key pair consists of course, a private key and public key. The way we use public and private key in digital signatures is a little different from when we're using our key pair to encrypt and decrypt a message for confidentiality. In this case, our goal is really to ensure integrity of the message instead of confidentiality. So that's the biggest difference, I guess, between the use of digital signature and encryption for confidentiality. So in the key pair we have a private key. In this case, in digital signatures, we use the private key to actually encrypt. In asymmetric key encryption, for confidentiality, we used private key to decrypt, but here it's the opposite. And then we also have a public key, but in this case, public key is used to decrypt a string. So private key of the key pair, whoever is encrypting using this private key is the owner of the key pair, and public key is distributed to the public, so anybody with the public key in this case can decrypt. So why are we doing all this? Because the goal here is to really prove the integrity of a message. If you encrypt something with your own private key, and if we can prove that you only have access to your private key, whoever is able to decrypt a string encrypted by your private key using your public key can prove that you actually sent that message to the person. So to give you a scenario, let's say Bob encrypts a string using his private key, and then Alice decrypts that string using Bob's public key, which proves that Bob is who actually encrypted the string, as long as we can ensure that Bob is the only one who has access to that private key. And this is basically the concept behind this thing called the digital signature, although it involves a little more than just encrypting and decrypting a string. In this case, in the digital signature scheme, we actually encrypt something called a message digest instead of any random string. So what is message digest then? A message digest is simply the hash value of a message. So the whole idea behind this message digest is that you can use this as evidence to check the integrity of the message. So for example, if the message digest, the value of that changes between sending and receiving of that message, that means the integrity of that message has been violated. So in a typical digital signature scheme, what we do is a sender typically encrypts this message digest using his or her private key, and then once the receiver gets that message along with the encrypted message digest encrypted by the private key of the sender, he or she, the receiver, decrypts the message digest. And then finally, if you compare the received message digest, the decrypted version, with the message digest of the received message, and if they match, what that means is the message hasn't been really changed during the trip between the sender and the receiver. So this is how you can make sure the integrity of the message. you can also prove that the message is actually sent by the sender who claims that he or she actually sent that message, because in this case the only person who knows the private key that was used to encrypt that message digest is actually the sender. So here is a diagram that shows the whole digital signature scheme as we discussed earlier. In this case, Alice is sending a message to Bob, and Alice gets a hash value, as you can see here, and then encrypts that hash value with her private key, and her public key is already available to the public. So for example, Bob has access to her public key already, so she sends the message together with this lockbox containing the message digest. The message digest is of course encrypted by Alice with her private key, and then once the Bob receives it, Bob will still get a digest of that received message, which is the hash value of the message, and then Bob will decrypt that message digest in the lockbox, and he will get that message digest value, which is also hash value of the message. And if you compare this hash value and that hash value, if they match, what that means is basically nothing happened to the message. The integrity of the message is guaranteed.